Hey, so today we're talking about assignment 48. Assignment 48. And what's this? Well, it's just a continuation of those word problems that we were looking at in the last video. I've got some more of those, perhaps another area problem, perhaps some more bearings to discuss. Let's take a look. Ooh, an oracular pig. Okay, and an assistant pig keeper. So, you're standing, or lying down if you prefer, on the top of a cliff, 5 miles high. And you know that the angle of depression to the assistant pig keeper is 5 degrees, and you know the angle of depression to the oracular pig is 35 degrees. We would like to know, how far is it from you? Well, if you're the assistant pig keeper, what's the distance between the assistant pig keeper and the runaway oracular pig? In fact, I'm going to use a D there. Okay. Any thoughts on how we might do this? Yeah. So I think we should build on that idea. Yes, there are 2 triangles here. X, 5. Hey, since this is 35, this must also be 35. Okay, and we have this larger triangle here. And it also has 5 miles. It's very tall. This angle is 5 degrees, therefore this angle is 5 degrees. Okay, and what's this length going to be? Well, that's x, and that's d, so I've got x plus d. And we're looking to solve this equation for d. Okay, can you write me an equation for each of these triangles? This one, it's going to be tangent of 35 equals 5 over x. So x tan 35 equals 5. Well, that's kind of nice, because then x equals 5 over tan 35. Now, once I know what x is, I can just plug that number in here, huh? I know for this, I can write tan 5 equals 5 over x plus d. And if I multiply both sides by x plus d, these will cancel, and I'll have 5 equals this stuff. In fact, I could even solve that equation for d. X plus d tan 5 equals 5. Well, if I divide both sides by tan 5, I've got x plus d. And so d is going to be 5 over tan 5 times, minus our x value, which was 5 over tan 35. Oh, isn't that interesting? 5 tan 5 minus 5 over tan 35. So what do I get? 5 divided by tan 5 minus 5 divided by tan 35. And I get 50. Oh, that's very interesting. D equals 50 miles. Wow. Yeah, good luck, buddy. If that's where the pig is, and that's where the assistant pig keeper is, that's 50 miles. Oh my goodness. Two triangles. Yeah, count on it. All right, how about this one? Oh, I know you're going to love this one. The octagon of doom, because, Costco is selling them now. It's a regular octagon, unlike the one I'm drawing, which is irregular. Yeah, that does not at all look like a stop sign. There, and there. That's a little better. Okay, so we've got our octagon of doom. And in this problem, we know that the side length is 12. All the sides are 12. And what we'd like to know is, what's the area of this octagon whose side length is 12? Can you do it? I think you should pause the video and try. We did the pentagon yesterday. Okay, so we did draw in the apothem, or apothem, no, and the radius. If this is 12, and this is 12, and this is 12, then this is 6. But what about these angles? How do I find these angles? Well, remember, phi was 180 over n, where n is the number of sides. We have 8 sides, so phi is 180 over 8. This is 45 over 2, so that angle, 22.5 degrees. Of course, if we're finding theta, the formula for theta, n minus 2 times 180 over 2n. Our n is still 8 sides, so 8 minus 2 is 6 times 180, and 8 times 2 is 16. So I could do some canceling here. I know 4 goes into 180 45 times, and I can take a 2 out of there, and I get 3 times 45, which is 105, divided by 2, and that's feeling, yeah, that's feeling like it's not quite right. Let's pull out the calculator. So I've got 6 times 180 divided by 16. 67.5 is right. Okay, so that angle, 67.5 degrees. So now I'm going to write a trig equation for what I'm looking at. Either I'm going to use 22.5 apothem and 6 to say tangent 22.5 equals 6 over apothem. And this is the one that I think is harder for kids to solve. Apothem, then divide by tan, 22.5. Sure, so 6 divided by, oops, not here, 6 divided by tan, 22.5, and I get that that should be 14.4. That should be 14.485. Okay, let's use this other one too, this 67.5 degree angle, opposite over adjacent. That would be tan 67.5 equals apothem over 6. And here, I do think the algebra is easier. I just have to multiply by that half side length. 6 times tan 67.5. Yep, same number, 14.48528137. Okay, so that's the apothem. Now, remember the formula for area of a regular polygon is 1/2 perimeter times apothem. So we've got the apothem right here. I want to multiply that times 1/2. And then I want to multiply by the perimeter. Now the perimeter is 12, 12, 12, 12, 12, 12, 12, 12, or 12 times 8. So my area, 695.294 square feet. Okay, enjoy the octagon of doom. That's when the side lengths are 12 feet. But what if instead of the side length being 12 feet, what if we enclosed the octagon of doom in a protective circle. Okay, we've inscribed the octagon in a circle. And that circle has a radius of 12. Now, I'm wondering, will the area of this octagon be larger than the area of the octagon when the side length was 12? What do you think? Well, let's find out. I'm going to draw that same picture. This is still my apothem. This angle here is still 22.5. That angle there is still 67.5. This is half a side length. I'm going to call that x. Okay? And I know that 2x is a side length for the octagon, and therefore the perimeter, which is 8 of these sides, I'm going to have 8 times 2x. So perimeter will be 16 times whatever I get for here. Okay, well, what trig function can you write for that? Well, isn't that interesting? Because we're looking for apothem, but we don't know this one. I do know this. Well, maybe apothem can be opposite over hypotenuse. Oh, sine. Sine of 67.5 equals apothem over 12. And what about this? Well, that's adjacent over hypotenuse. That's cosine. 67.5 equals x over 12. And so I'm going to multiply both sides by 12 in both equations. And 12 sine 67.5. I get apothem is 11.08655439. That's the apothem because I multiply both sides by 12. And here when I multiply both sides by 12, 12 cosine 67.5, that gives me 4.5922011188. Now remember, this is that half of a side length. So if I multiply this number by 2, I get a whole side length for the octagon. And because I need perimeter, I really want 8 of those sides. So 16 times this, times 16. And I get that perimeter is 73.475 to 1901. And here's our apothem. And remember, the formula is 1/2 perimeter times apothem. And yes, I could very well imagine being the type of teacher who does not give you that formula on the test. And so you really do need to memorize it. 11.08 655 I've got 407.293 square feet. Yes, this octagon is smaller. Why? Because we know that 12 is longer than hypotenuse. 12 is longer than this side length. Whenever we have more than 60 degrees at hand. If we had 60, all these would be equal. We have an equilateral triangle because all the angles would be 60. So whenever this angle is bigger than 60, it's going to be a much smaller area. Okay, so there's 2 area problems for you. Guess what's going to be on the assessment? Yep, one of those. So, ask Mr. Paz or myself if you need some more help. Okay, next. Please imagine that you are a little hopper. Okay, and you decide one day to go visit Cactus Wren. And Cactus Wren, in order to get to Cactus Wren's house, you have to go south 20 degrees west. So there's your house. And now you're going to Cactus Wren's house 10 kilometers, a little morning sprint for you. And then Cactus Wren says, hey, why don't we go to Circle K? So off you go to Circle K on a bearing of north, 70 degrees west. 70 degrees. Okay, and that's 12 kilometers. Okay, so you get here. And on what bearing does you, the Avelina, have to take to get back home? Okay. On what bearing are you traveling? Well, you can do this one of two ways. You can say, I gotta go north, something east, or I've gotta go east, something north. Okay. Now I know that this angle is 70, and that's a right angle. And because parallel lines cut by a transversal, I know that that's 70 as well, which means that this angle here is 20. Now our bearing angle is this one up here. Now that's actually inside the triangle, right? I mean, this is my triangle, and I've got I don't know what and 20. Could I find theta? Sure. Opposite, adjacent, it's tangent. Tangent theta equals 10 over 12. So theta is going to be tangent inverse of 10 over 12, or 5/6. Let's see what we get. Inverse tangent of 5 divided by 6, and I get 39.8055719 degrees. So this angle is 39.805. And this part is 20. So how big is my bearing angle? Well, that number minus 20 gives me, I need to go 19.806 degrees. Now be careful, because this is that 19-degree angle, and so for this angle we actually have to go east and then north. If I want to go north and something east, well, that's going to be 90 minus that, and so we would have north 70.194 degrees east. So either of these answers would be correct. Okay. There you go. See, you can do bearing problems. Don't be scared. Okay. Next. Did that one? Did that one? Ooh. More. Oh, look, there's more over here. Oh, yeah. Green sea turtles. Oh, my goodness. I just couldn't believe this when I heard about this. So it seems that there are these giant turtles in the ocean. These particular sea turtles, these giant green sea turtles, they swim the Atlantic, and they go, let's see, from Rio to Ascension Island. Okay, so here's what happens. They feed in Rio, off the coast of Rio de Janeiro in Brazil, and so that's where this trip starts. And they swim north 47 east for, no kidding, 2,000 kilometers. 47 north, 47 east, until they get to this place called Ascension Island. I'm not making that up. This is where they eat. This is where they lay eggs. And then once the babies are able to swim, they leave Ascension Island and go to Cape Town. They actually spend a good chunk of the year off the coast of Cape Town, which is always great for tourists. And we're going to go south. Too many lines over here. We're going to go south and 43 degrees east. So south, 43 degrees east. Originally we went north 47 degrees. Now we're going south 43 degrees. And they actually, we thought that was a long swim, 2,000 kilometers. This one is 4,150 kilometers to get to Cape Town. And they swim off the coast there in Cape Town. But, you know, after swimming for a while and hanging out, they realize they're hungry. And so it's time to swim back to Rio. So, of course, our two questions are going to be, what's this distance? And on what bearing do they need to go from Cape Town to Rio? And I promise I researched all this myself. These are the actual values. And so if we're going from Cape Town, I suspect we're going to be going north and this much west. Of course, you could go west and this much north, but this is outside of our picture, and usually that's a little harder than the stuff that's inside our picture. Okay, so, well, because these are parallel lines cut by a transversal, this must be 47 degrees. 47 plus 43 is 90. So we've got a right triangle here. And we know that this is 2,000, this is 4150, and that's got to be longer than either of them. So Pythagorean theorem says 2,000 squared plus 4150 squared, and don't forget to take the square root. And that's going to be 4606.788 miles? Kilometers. Okay, if we divide by 1.6, that's almost 3,000 miles. Like driving from our house to Boston. Okay, yeah, and they're swimming the whole thing, right? I mean, it's just amazing to me. So that's great. We know the distance. There's part A. Part B. On what bearing? Well, let's see what I know. I know that these lines are parallel, and this transversal cuts, so this angle here must be 43 degrees, like that angle there is 43 degrees. But 43 degrees isn't my bearing angle, because I'm going to go north that many degrees. I've got this. That's 43. But what about this piece? Well, I need to find theta. Oh, well, no problem. You could use sine opposite over hypotenuse or cosine adjacent over hypotenuse. But if for some reason I made a mistake here, then now I'm automatically going to get the bearing problem wrong if I use this one. These were given to me, so I'm going to use those to find theta. I'm going to say tangent theta is 2,000 over 4150. And so if I take the inverse tangent to both sides, second tangent 2,000 divided by 4150, and I get that theta should be 25.7307056 degrees. Great. Remember though, our bearing angle is this red one, which is made up of the 43 and the theta. So 43 plus 25, I'm going to have 68.731 degrees. And for us, it's head north and then something west. So there's my answer. That's the bearing on which the sea turtles need to swim in order to get to their feeding grounds in or off the coast of Rio. All right, what's next? I'm looking at, I actually did this one once. So we've got a swamp. Ugh. Sorry. A, C, and the other side of the swamp. And this is 50 meters. So the surveyor wants to know how far that is. And we know that it's 50 meters from A to C. And when they take a bearing, 32 west, yeah. When they take a bearing from A, that angle, north, 32 degrees west. Okay. If they take a bearing from C, they're going to have north 68 west. So this is 68 degrees here. Okay. And what do we want to know? Well, we want to know what that distance is, AB, and we want to know the bearing from A to C. Okay, well, let me get rid of the swamp, because that actually makes it really hard for people to see the triangle and the little there we go. Okay, so compass rose, that's 32 degrees. I have another compass rose. Can't draw a straight line to save my life today. There we go. That's better. We know that's 68 degrees. We know there's a right angle here. So if that's 68, this must be 22 degrees. Okay. What else do we know? Oh, sorry. This was in the picture. I forgot to draw it. So I know there's a right angle there. And I know that this angle is 32. This is also a right angle here. Okay, so, oh, I see. If that's 32, then this must be 58 degrees. Okay, and since there's a right angle here, that's 58. That's again 32. Oh, and look, parallel lines cut by a transversal. These are alternate interior angles, so that's 32. Oh, isn't that nifty? So this whole angle, 22 plus 32, is 54 degrees. Oh, well, I think this makes a lot of things much easier. And what bearing? I wanted the bearing from A to C. Oh, well, I got that. I go north, 58 east. And I could write east, 32 degrees north. I head east and a little bit north. So there's my bearing. And we were also supposed to find D. Okay, well, I can do that because, look, I'm just looking at this right triangle with 50 and D, and I now know that this angle is 54. So, yeah, that's just a regular old tangent. 54 equals D over 50. So if we multiply both sides by 50, 50, 10, 54, 50, 10, 54. I'm going to get 68.819. 68.819, and these are meters, to get from A to B. Nice. Okay. We did that. We did the oracular pig. Yeah, I think I'm gonna stop there. We've certainly got more problems we can do. But I think if you want, stick around and ask for more of these, or if you want, send something in GroupMe saying you'd like some more practice. I can get you some more practice. Or Mr. Paz can. We're both here to help. Let us know how we can. Okay, take care, everyone.